Friends, I discussed combination reaction with examples in my previous video. In this video, I am going to discuss decomposition reaction, types of decomposition reaction and endothermic reaction with examples. Watch the video with total attention and master the subject knowledge. Only then you will be able to answer the questions given in the last part of the video. Consider the following chemical reaction. Calcium carbonate on heating decomposes into calcium oxide, that is quicklime, and carbon dioxide. The chemical equation is CaCO3 solid upon heating decomposes into CaO solid plus CO2 gas. That means a single reactant CaCO3 on heating decomposes into two products, namely CaO solid, that is quicklime, and CO2 gas. Such a reaction is called a decomposition reaction. Let us define it. Decomposition reaction is a chemical reaction in which a single reactant decomposes into two or more products. A single reactant decomposes into two or more products. It is the reverse of a combination reaction discussed in my previous video. The decomposition reaction in equation 1 is possible only by supplying thermal energy, that is heat, to the reactant. Therefore, such a decomposition reaction is called thermal decomposition. Now, let us consider some more examples of thermal decomposition reaction. Consider a chemical reaction that occurs on heating ferrous sulfate crystals, which are light green in color. Ferrous sulfate is in hydrated form, that is, it is associated with 7 molecules of H2O. On heating, it first loses the water molecules and becomes colorless, that means anhydrous form. It then decomposes into 3 products, namely ferric oxide solid, sulfur dioxide SO2 gas, and sulfur trioxide SO3 gas. The chemical equation is 2FeSO4 solid upon heating decomposes into Fe2O3 solid plus SO2 gas plus SO3 gas. Let us consider another decomposition reaction. Lead nitrate solid on heating decomposes into 3 products, namely lead oxide solid, nitrogen dioxide gas in the form of brown fumes, and oxygen gas. The chemical equation is 2PbNO3 twice upon heating decomposes into 2PbO solid plus 4NO2 gas plus O2 gas. The chemical equation 3 is an example of thermal decomposition reaction. Let us consider another type of decomposition reaction, namely electrolytic decomposition. Let us define that first. Electrolytic decomposition is a decomposition reaction in which a substance is decomposed into products by using electrical energy. Electrolysis of water to produce hydrogen gas and oxygen gas is a famous example. The equation is 2H2O liquid gives rise to 2H2 gas plus O2 gas upon electrolysis. Now let us understand this simple experiment. Take acidified water in a beaker. Acidified water means add a few drops of sulfuric acid to water. Insert in it two electrodes, carbon rods as electrodes, both anode and cathode. Positive polarity electrode is called anode and negative polarity electrode is called cathode. Connect these two electrodes to a battery of 9 to 12 volts. Then electrolysis starts, and electrolysis of water produces hydrogen gas in the form of bubbles you see here at cathode, and oxygen gas in the form of bubbles you see here at anode. We have already seen the equation as 2H2O liquid gives rise to 2H2 gas plus O2 gas. Let us understand yet another type of decomposition reaction, namely photolytic decomposition. Let us define that. Photolytic decomposition is a decomposition reaction in which a reactant on exposure to light decomposes into products. Silver chloride, AgCl, on exposure to sunlight decomposes into silver metal, Ag, and chlorine gas, Cl2. The corresponding equation is 2AgCl solid upon exposure to sunlight gives rise to 2Ag solid plus Cl2 gas. Another example is silver bromide, AgBr, on exposure to sunlight decomposes into silver metal and bromine gas. The corresponding equation is 2AgBr solid upon exposure to sunlight gives rise to 2Ag solid plus Br2 gas. The reaction expressed in equation 6 finds application in black and white photography. Now, we have seen in some of the reactions, thermal energy is absorbed by the reactant, and such reactions are called endothermic reactions. Let us define that. Endothermic reaction is a chemical reaction in which the energy in the form of heat, that is thermal energy, is absorbed by the reactant, and then the reactant decomposes into two or more products. The chemical reactions expressed in equations 1, 2, and 3 given above are the examples of endothermic reactions. That means heat is absorbed by the reactants and they decompose into products. Again, they are reproduced below. CaCO3, heat gives rise to CaO solid plus CO2 gas. 2FeSO4 solid, heat, Fe2O3 solid plus SO2 gas plus SO3 gas. 2PbNO3 twice solid, heat, 2PbO solid plus 4NO2 gas plus O2 gas. Most of the decomposition reactions are endothermic reactions. That means heat is absorbed by the reactant and then the reactant decomposes into products. However, a few decomposition reactions are exothermic also. That means heat is released in the reactions. One example is 2H2O2 liquid, hydrogen peroxide, decomposes spontaneously into 2H2O liquid plus O2 gas plus heat. Heat is released because it is an exothermic reaction, right? But most of the decomposition reactions are endothermic, but there are a few exothermic reactions like hydrogen peroxide decomposition. Now self-assessment please. Question 1. Which one of the following is a decomposition reaction? Zn plus FeSO4 gives rise to Fe plus ZnSO4. Option B, 4Al plus 3O2 gives rise to 2L2O3. Option C, 2KClO3 solid upon heating in the presence of MnO2 catalyst gives rise to 2KCl solid plus 3O2 gas. Option D, NaOH aqueous plus HCl aqueous gives rise to NaCl aqueous plus H2O liquid. Please choose the right option. Second question, which one of the following is an endothermic reaction? Option A, CaCO3 solid gives rise to COO solid plus CO2 gas. Option B, 2H2 gas plus O2 gas gives rise to 2H2O gas. Option C, CH4 gas plus O2 gas gives rise to CO2 gas plus 2H2O gas. Option D, COO solid plus H2O liquid gives rise to CaOH twice aqueous. Now, I have given two questions based on assertion and reasoning, right? You have to choose the right combination of assertion and reasoning among the given options. Question 3. Assertion, which is denoted by capital A here. See, most of the decomposition reactions are endothermic reactions in nature. Reason, denoted as capital R. Energy is released in endothermic reactions. So, assertion is given A, reason is given R. Now there are four options. Option A is wrong and R is correct. Option B, A is correct and R is wrong. Option C, both A and R are wrong. Option D, both A and R are correct. Choose the right option after careful thinking. Question 4. Assertion statement is 2H2O2 liquid gives rise to, decomposes into 2H2O liquid plus O2 gas is an endothermic reaction. Reason, or energy is absorbed in this reaction, right? So assertion is given, reasoning is given. Now there are four options. Option A is wrong, that is assertion is wrong, and R is correct, that means reason is correct. Option B, A is correct and R is wrong. Option C, both A and R are wrong. Option D, both A and R are correct. Now I have given some other questions also. Define decomposition reaction. Give any two examples of thermal decomposition reaction with the balanced equations. Question 2. Define electrolytic decomposition and explain with an example. Question 3. Define photolytic decomposition. Give one example with the equation. Write one application of photolytic decomposition. Question 4. Define endothermic reaction. Give any two examples with equations. Question 5. Write decomposition reaction which finds application in the manufacture of quicklime. Now conclusion. After understanding the concepts, you have to solve many unknown questions and problems. Periodically, you have to revise the concepts and solve a few more unknown problems. If you master the knowledge and also the skill how to answer different types of questions, you will be motivated to learn further and further. That leads to deep learning. I wish you the best in all your efforts, my dear students.